I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, March 21st.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, yes, we have a gale just over the dateline with seas in the 24-25 foot range and pretty well at Hawaii and the U.S. West Coast. This is actually kind of a surprise. It wasn't expected, or not at least at this magnitude, and at this time of the year, we'll take whatever we can get. So let's dive into the details. We'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, and we have a good example of one right here over the dateline, and of course that is what is feeding the gale that is developing there. See, winds in the upper atmosphere, they fall south, and what that helps do is create a counterclockwise flow aloft and down at the surface, and that is the hallmark of low pressure. And if that low pressure is strong enough, it generates winds. If the winds are strong enough, they generate seas. If the seas are high enough, as they radiate away from the fetch area, they turn into swell, and swell, of course, when it hits your beach, turns into surf. Right, so we have a decent trough here. Now notice, the jet's pushing off Japan. It actually splits with some of the energy going south here, sort of vaguely moving over Hawaii and into Baja. But the main energy goes to the north here, forming the trough that we were just talking, and then from there progresses through the Gulf of Alaska and into over Vancouver Island. Let's put this into motion. Oh, and also notice that winds are pretty decent strength pushing down into the trough. The stronger the winds pushing into the trough, the greater the odds for circulation aloft. All right, so, and as we get into Monday, notice winds build to about 140 knots towards the apex of the trough as it approaches a point northwest of Hawaii. But also notice later on Monday, the trough starts pinching off. And as that happens, it really kind of hinders. You can't get a good round circulation. You get this kind of pinch thing, and that doesn't do a whole lot for gale development. Also notice a big ridge on either side of the trough, and ridges typically support a clockwise flow, and a clockwise flow is the hallmark of high pressure. So one would expect high pressure at the surface here and here, weak low pressure here as we get into Tuesday morning. Also notice a bit the jet pushing down the coast, maybe some sort of a backdoor front pushing down somewhere in here, maybe inland on Tuesday, but you know, nothing of any particular consequence. Now notice the low fully cuts itself off as we get into Wednesday. The jet, pretty much a mess. Most of the energy pushing way north up into the Bering Sea and then inland over Alaska and down the interior U.S. Our cutoff low here and the remnants of the southern branch of the jet doing what it's been doing pretty much for months now. Basically nothing. All right, we get into Thursday. Even the cutoff portion of the jet, it tries to reorganize, tries to connect with the main branch of the jet, but just can't seem to quite get anything together. Another trough, theoretically, on Saturday, pushes off the Bering Sea and moves towards the North Dateline region. The latest runs of the models have suggested this looking a little bit more positive, but I think is given it's a week out and given the time of year, I'd say and the lack of winds here in the models suggests probably not a whole lot happening. And otherwise, big ridge over the Gulf of Alaska, high pressure. It's the spring season. Typical, you would get a lot of north winds along the coast, east winds into Hawaii, and that's exactly what has been going on. But let's go take a look down the surface, see what is actually going on. We can infer things from the upper level flow, and it helps us gauge energy levels and gives us a sense of what these surface projections, how real they are. If you don't have good upper level flow, typically whatever is projected, especially when you get 3 and 4 days out in the model, it typically never materializes if it doesn't have upper level support. All right, so right now we have a little low pressure system over north of, we'll say North Japan. 40-knot winds off the coast there, but all aimed north, doing nothing. Here's our main area of focus, this gale, with 45-knot winds over just east of the dateline, producing fetch aimed at Hawaii and the U.S. West Coast for the moment, and another weak low up in the Gulf of Alaska, really doing nothing. Our low in the dateline remains, over the dateline remains our focus. It sort of lifts north as we get into Monday and Tuesday, 35 to 40-knot winds. Hawaii probably is going to be the main focus since all the fetch is aimed right at them. And then even as we get into Wednesday, now remember the jet pinches off and there, boom, the low just disappears. Its upper level energy source gets completely just eliminated. Now we do know that it's sort of a cutoff low, tries to organize here, and you see that at the surface right now, some sort of a low with up to 40-knot winds as we get into late Thursday and Friday, again aimed at Hawaii. So there's some possibility there for something. Also another low pushing off Japan, forecast with 25, 30, 35-knot winds, almost 40-knot winds. We'll see about that. And then to 45 knots, mainly all line north and south, no real fetch, a little bit there aimed at Hawaii. Well, the jury's out on whether that's really going to do anything or not, but we'll keep our eyes on it just in case. Where are we? We're on Saturday, and that low, this is the low that then is forecast to push over the North Dateline region with 40 to 45 knot winds. Looking decent if you believe the models, and then we're out 180 hours. So we'll keep our eye here. We're not betting on any of that. The low over the dateline in the next couple of days is probably going to be the main area of focus. Let's go take a look at the effect of these winds on the ocean surface. And before we get into that, we sort of want to say a goodbye to the WaveWatch 3 wave model. Theoretically, on Monday, so it was supposed to change over last Wednesday. There was a major weather day, they call it, so they don't do significant software infrastructure cutovers when you have significant weather going on. So they've rescheduled to Monday, tomorrow morning. The NOAA OMB WaveWatch 3 wave model will cease to exist. It is going to be consumed or ingested into the GFS model, Global Forecast System, which is a reasonable place for it to be, and the resolution will go up significantly, like 9 times. It was running on I think it was a half-degree grid square. That's you see these squares here? I mean, these are actual latitude, longitude lines, but the model actually works the same way. It draws squares all over the face of the Earth and then computes wind, pressure, temperature, precipitation from the surface and in I think it's 50 millibar increments the whole way up to the jet stream and above. Well, and those grid squares are a half a degree each. The GFS, I think, is running actually at 25, but the global model for the wave model is a half degree right now, and it's going to be going down to significantly less than that, a sixth of a degree. So much more resolution, the thought being that it will become much more accurate, and under the covers, the updates will actually be, the increments that they display will be hourly, going out to 120 hours, and it will go out 2 weeks, and all this kind of stuff. Now, again, the same holds true. We don't believe any model going out even a week, much less 2 weeks. But at some point in time down the road, we might start, extend some of our charts and give just the global wave model, run that out for 2 weeks. But first off, we got to make the hurdle of just getting onto the new model. So for sure, things are going to fall on the floor tomorrow morning. We've done a bunch of testing. We think we're pretty well prepared, but not completely, and just expect that there will be issues, but we'll do our best to get like the North and South Pacific models up, as they're going to take priority, and then everything will stack up behind that. All right, so today here's our gale, 25-foot seas over the dateline. As we get into tonight, seas build to 27 feet and then 28 feet later tonight. Then starting to fade from about 22, 24, 22, 24, 26, 27 feet, 26 and a half feet. Monday morning, fading from there. Certainly some energy moving towards Hawaii and the U.S. West Coast. don't expect a whole lot for California. Nuking north winds will probably just mar whatever swell that gets generated. So, hate to rain on the parade, but that's, but Hawaii is due their time. They've had much less than California lately. And then the system redevelops. You can even see the wind swell heights here. What is that? That's just eyeballing it. That's about 16 or 17 foot seas just by local winds alone over this little area right there. So that's a lot of wind. Anyway, again, we get into 23 foot seas on Friday, aimed reasonably well at Hawaii. And then the new gale develops as we get into Saturday, supposedly off the North Kurile Islands, pushing over the North Dateline region now with, this is much better than it was even in the last run of the model. 34-foot seas pushing over the North Dateline. So theoretically, we could get some swell from that, but we're not holding our breath. And then theoretically, as we get into the weekend, next weekend, winds die out along California. You see the seas just evaporate. So we'll see how that plays out. Going back a week and looking down south, a tiny gale developed. I think we talked about this last week. Lifting north, producing, what was that, maybe 30, 32, 34, 35-foot seas. We're just going to look at this for a second. And lifting well to the north. Swell is in the water, expected to arrive, I think it's tomorrow, Monday, mainly Southern California sort of thing. Size really small. I mean, look at the size of the scale. Tiny in coverage. Seas not that high, but something for exposed breaks in Southern California. New system also developed right behind that, stronger off the right Ross Ice Shelf. Notice how far depressed the Ross Ice Shelf is, because it is the summer down there. But that's ending quickly. Seas built to 43 feet, and then that lifted sort of northeast, so there's another swell behind that. Again, not huge size, but maybe something respectable for Southern California. We're not holding our breath for Northern California. And then another tiny gale developed under New Zealand on Tuesday, Wednesday of last week. That produced a little bit of seas. That'll be swell for Hawaii and hardly anything negligible for most exposed breaks in Southern California. But then a broader one behind that developed. 30-foot seas over a tiny area under New Zealand, but that sort of faded out pretty quick. And then as we get into Saturday and Sunday, today, a new gale is starting to form under New Zealand, lifting northeast with 28 to 30-foot seas. And all that is confirmed. Now we're going out to the model, and you see a much broader area of 30-plus foot seas is forecast as we get into Monday under New Zealand. What is that? 30, 32, 34, 35.4 feet in this one little pocket there. Lifting northeast, pushing over into almost the central South Pacific into late Tuesday. So swell should result from that if that develops as forecast. And then theoretically, some other sort of gale starts developing again also on Friday in the South Central Pacific, moving to the Southeast Pacific with 38-foot seas. That would be great. Almost 40 feet, 39-foot seas, and in both the all of the California swell window, pushing east from there and out of the window, but still aimed at Chile and Peru. So swell possible from that, and yet another behind that. You think we're moving from winter into summer for sure. We have one lousy gale up north and a whole string of systems developing in the South Pacific. So that's where we are. We're moving towards summer. It's pretty much for sure now. Next up, wind swell production. High pressure, 1038 millibar in the Gulf of Alaska, locking things down, but generating north winds as typical along the coast. And during a La Nina year, you would expect high pressure to be much stronger than normal, and that would mean more north winds than usual in the spring along the California coast and stronger than normal trades pushing into Hawaii, and that's exactly where we're at. 20 knots along California today, 20 plus knots pushing into the Hawaiian Islands. So we get into Monday, pretty much more of the same. Yeah, trades back off a little bit from Hawaii associated with the low in the Gulf. You can see it there, but relative to California, as we get into Tuesday, 25 to 30 knot northwest winds raking the coast. Trades pushing towards Hawaii, not reaching there. Maybe there'll actually be some wind swell from that as it radiates to the west. And then we get into Wednesday. Look at this 30-knot north winds off of Cape Mendocino, but also notice light winds south of there. This is the typical summertime pressure gradient. We'll see how long it lasts, though. Yep, there you go. 35-knot winds Wednesday evening, and then raging in control on Thursday, 25 to 30-knot winds all along the coast in the afternoon, almost 35 knots. But maybe protected breaks down here in central California would be okay. Trades light for Hawaii with low pressure circulating to the north. Get into Friday, then all of a sudden everything starts fading out. Lighter wind regime sets up, and wind swell pretty much backing off as we get into Sunday. And let's see, that's about there. We were 180 hours out. A little bit of wind, maybe late Sunday night, but things dying down, at least in terms of wind swell production. Precipitation forecast. With high pressure in control, the odds for precipitation are pretty slim. We're keeping our eye right here, and we're just going to blast through this. Yeah, a little bit of rain for Cape Mendocino on Monday. Maybe even some flurries up there for, we'll say, Tahoe. Monday night into Tuesday, and then high pressure in control. You notice the dividing line is like right here. That's where it's been all year, somewhere between Cape Mendocino and the Oregon border. Oregon's got piles of snow, so does Washington. California, I think I looked just yesterday, I think we're about, precip-wise, somewhere hovering in the 37 to 40%. 40% for this time of the year, 37% for the whole precip year, and that's probably going to be about it. We're just clicking through the model here. Nary a drop of precipitation forecast. Oop, there we go, and we're out a week. So what is it, tomorrow, and that's about it for Tahoe and Cape Mendocino. A quick look at the snow forecast dashboard. What is this, maybe an inch for Squaw Valley. We're not even going to go look at the other resorts, just a dusting of snow. That's about it. The temperature profile, here's the interesting thing, and you can see the trend upward. The red is above freezing temperatures. The gray is slush if there were precipitation. This is the base of Squaw. This is the top of Squaw. So you see freezing level right now, theoretically, right around the base somewhere, and maybe into tomorrow like that. Then after that, it kind of nudges up a little bit, and as we get into the 27th, the 28th, the freezing level is up above the top of Squaw, up at 10,500 feet. That's above pretty much every resort in Tahoe, and approaching the summit for even Mammoth. I think their peak's at 11,000 feet. So clearly a signal of the change of seasons. Springtime, for sure, moving fully in. Will we get another dip where temperatures drop and we get precipitation? Probably not. We'll talk a little bit about that in the long-term forecast. And so queued right up, the long-term outlook. What's going on with the Madden-Julian oscillation and, of course, El Nino or La Nina? Well, we know we're La Nina, but how much longer? Maybe not too long. All right, as usual, we start looking at winds across the equatorial Pacific to give us some sort of clue of what's going on with the Madden-Julian oscillation. The MJO is that periodic oscillation that travels from west to east around the planet on the equator. And when there's two states, inactive and active state. When in the active state, and that's the one we're most interested in, it helps fuel, it can actually reduce trade winds, change the trade wind's direction, imparts energy to the jet stream both in the north and southern hemisphere, and can promote storm production. Also, it can be, when the active phase of the MJO is over the West Pacific, it can reverse the trade winds there and take warm water that's normally pulled up on the ocean surface there and start pushing it to the east, not on the surface, but underneath the equator, down about 150 meters. And it takes about 3 months, but once that warm water migrates across the Pacific, it erupts near Ecuador, moves to the surface, can create a warm water pool there. And if you have successive that's known as a Kelvin wave. If you have successive Kelvin waves, that can help fuel El Nino. So we're always on the lookout for, one, a series of strong active phases of the MJO, because that is great for surf production, and two, it can push you into El Nino, or can be at least warm up ocean temperatures, and you don't have to be in El Nino to get the benefits from an El Nino-like pattern if ocean temperatures are warm along the equator. All right, so what are we looking at? This is data from the TAO buoy array, series of buoys strung across the equator. This is the East Pacific here. So California is about 120 west, 118 Southern California. Ecuador is over about 80 west, so just off the picture. And then that's New Guinea there, dateline there. There's your equator. The Kelvin wave generation area, we call it. This area in the far west Pacific from 170 west, just 5 degrees north and south of the equator. Okay, so winds. We're just looking at the arrows. The colors are ocean temperatures. Winds out of the east, pretty brisk, but not too horribly bad in the East Pacific. Same thing over the Central Pacific. And in the Kelvin wave generation area, east winds. But it is the anomalies, the differences in wind speed for this time of year. Yeah, winds are pretty strong out of the east. These arrows are suggesting, yeah, they are stronger than normal for this time of year, so that's not so good of a thing. It's an offshore flow, an upwelling flow. Over the Central Pacific, yeah, winds are out of the east, but look at, there's no arrows, meaning that's actually, those winds are weaker than normal for this time of year. Then the Kelvin wave generation area, winds have actually backed off pretty much. I mean, they're still out of the east, but not very strong. They've been raging since last April. And of course, we've been in La Nina, right? So that would be expected. But at least for the moment, the Kelvin wave generation area is getting a bit of a break. And keep that in mind as we start talking about ocean temperatures and subsurface ocean temperatures in just a minute. All right, so what is the wind going to do for the next week? All right, we got a sort of a funky chart here. It's the whole planet, the east-west component of the wind, all on one chart. All right. The blues are easterly anomalies. The yellows, reds are westerly anomalies. The active phase of the MJO, when it's over the Kelvin wave generation area, the West Pacific, should typically produce west anomalies, and that's what we want to see. All right, so where are we here? The date line, 180 west, goes right up the middle of the chart. Kelvin wave generation area, far West Pacific starts about 135 east, so right about there. And the east Kelvin wave generation area right about there. Okay, and California is right around right there, going the whole way up the chart. Right, so notice California was here. The yellows were westerly anomalies in March, and they kind of held on until just the past couple of days. We were getting rainfall and precipitation. This would suggest the active phase of the MJO was maybe south of California. You could actually see it almost moving across like that. And that was supporting our rainfall and our cold fronts and snow and all that sort of thing. But now look at what we got. Deep blues, strong east anomalies forecast to build in the Kelvin wave generation area starting today, go for the next week. That's clearly a sign of the inactive phase of the MJO. And if you look here, those easterly anomalies, as one would expect, are supposed to migrate south of California by the end of the week. That would certainly support the buildup of high pressure and the unlikeliness of there being any rainfall anytime in the next couple of weeks. Right, so here's another component of the MJO, outgoing long wave radiation. Fancy words for cloud cover. Where the blues are, there's more cloud cover, less sunlight reflectivity off the ocean surface. That would be the active phase of the MJO, because the active phase is like a low pressure system, so it creates a bunch of clouds. The inactive phase is the equivalent of high pressure, just clears out the clouds, a lot of sunlight reflectivity off the ocean surface. So where are we here? Equator EQ right there, runs right through the middle. There is South America, Central America, Hawaii, Australia, New Guinea. Kelvin wave generation area right there. Oh, there's the date line right up there. Okay, and there's 4 panels. They're all the same. You get the idea here. Inactive phase of the MJO today, 5 days from now, still over the Kelvin wave generation area, but weakening more 10 days out, and all but gone 2 weeks from now, according to the statistic model The dynamic model actually saying pretty much the same thing, a variation of that, with the active phase building over the maritime continent and then primed to push into the Kelvin wave generation area. The statistic model not so strong or so sure about this active phase 2 weeks out. And again, do we believe a model 2 weeks out? Well, probably not, but it gives you at least a rough idea. Next up, phase diagrams, a way to sort of drill into the details of both the statistic and the dynamic model. What are we looking at here? All right, well, assume the equator runs around the outside of the frame. This is like, assume you're looking down on the North Pole, and then the MJO runs west to east from the Indian Ocean over the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is, right there, is where the active phase is today. And the closer that dot is to this circle, the weaker it is. So a very weak active phase of the MJO today, we'll say over North Africa. And, I'm sorry, there's the heavy dot. What was I thinking there? All right, so over the West Indian Ocean. All right, and it is forecast to move to the maritime continent. But notice each one of these dots is a day, 14 days out, are all inside the circle, extremely weak and of no real interest. Per the statistic model, the dynamic model now, though, says no. Look at the active phase. We'll call it weak, but maybe modest in strength over the East Maritime Continent, trying to move towards the West Pacific 2 weeks from now. So a bit of disparity between the two models. We'll have to see how this plays out. All right, so again, let's go look out now a month. This is one of those charts. Again, whole plan on one chart. Dateline runs right up the middle. The far West Pacific right about there, 135 east. The California right around here. Now, here's that other thing we talked about it earlier. The west anomalies are the reds, the oranges. East anomalies are the blues. So back here in March, we had west anomalies south of California, and you get the hints of the active phase of the MJO sort of in this area south of California or moving to, and that supported our precipitation. Then you see this, the inactive phase of the MJO, moving its way across over the next month into the Kelvin wave generation area today, building strong east anomalies. We saw that. We know it's happening, and it's only going to get worse. But fortunately, only for about a week, this says. Then the east anomalies, they continue, but they fade. They're not very strong. Notice this pretty strong active phase, forecast building all the month of April, and maybe starting to ease into the Kelvin wave generation area mid-April or so. Also notice these east anomalies, the inactive phase, providing or building east anomalies south of California for the next month. Not a hope of precipitation likely when that happens, because what that does is support high pressure in the Gulf of Alaska. So the chance for significant precipitation for at least California are probably pretty thin from here on out. At least that's what this model suggests. Then finally, the 3-month CFS model. This is going way out into the future. Past performance is in the bottom. The forecast is at the top. The Kelvin wave generation area from here, up to 170 west right there. See our big pool of easterly anomalies, the La Nina signature that occurred in January, a little bit of an active phase of the MJO, and now east anomalies again building and forecast in the Kelvin wave generation area into somewhere about, we'll say, the first week in April, something like that. But then notice this, a pretty strong active phase building, and another one behind that, a little bit of easterly anomalies, but maybe this will suggest a change in the pattern. All right, and we'll put this in, there we go. Okay, so the overlay, the dotted contour here is the inactive phase of the MJO. The solid contour is the active phase of the MJO. So we got to suffer through, what is this, a week and 2 weeks? Yep. about 2 weeks, 2.5 weeks, and then the active phase sets up. Theoretically, when this sets up, it'll impart energy to the jet both north and south. Probably this will have a better effect in the southern hemisphere than the northern hemisphere once you're into April. And it's pretty strong westerly anomalies forecast. Of course, they give way to a stronger inactive phase behind that, but then yet a stronger active phase behind that. The MJO, you notice here, has been one contour, whatever, inactive, active, maybe two, but then you start building to 3 and 4 contours, and the MJO has been exceedingly weak all winter, and it would be normal at some point for it to wake up, and when it does, that will start pushing things in the atmosphere. You start getting some momentum going, and that helps feed the storm track. So whenever that happens, that would be a good thing. Low pass filter. Now, what is really driving all this? Well, so the dotted contour is high pressure, the high pressure bias, and it's right over the date line, right in the middle of the Kelvin wave generation area. This is La Nina, and the low pressure bias is over the Indian Ocean. Again, a classic La Nina symptom. If you read the paper or looked online, they're talking about floods and a lot of water over in East Australia. That's certainly not a El Nino situation. That's a typical La Nina scenario where the low pressure bias is over Australia. They get piles of rain, and we sit high and dry in the Pacific until it flips, and then we go to El Nino. Then what happens? I remember the big El Nino 82, 83. Literally, Australia was burning, rat infestations in their wheat supplies. It was in their grain supplies. It was really bad. They were high and dry, and we were getting soaked in 82, 83, and then also 97. The same thing goes on. All right. So anyway, the low pressure bias. Now this is the key. Notice we go from 4 contours to 3 to 2 contours by about mid-May, and then only 1, and the 1 high-pressure bias contour is completely out of the Kelvin wave generation area as we get into maybe the first week in June or so, and the low-pressure bias starts easing its way into the West Pacific and almost, not quite to the dateline yet, but trying to move its way there. That would support this idea of stronger active phases of the MJO in the Pacific, and that's exactly what we want to see happen, because that will do great for storm production and then maybe set us up for precipitation next fall and winter. Just one quick sidestep here. January 2020. This is the strength of the active phase of the MJO, and you notice as we got into 2020, the MJO just was weak. Nothing compared to the year before. Notice almost up to, 3 standard deviations. We were hanging down around, well, this is neutral. Actually, I'm not sure what these numbers are, but we'll call this, 1, and this is a 2. All right. Look back in 2018. Oh, this was, I think, a La Nina year, 2017. Look in 2015, that was a major El Nino year. So the amplitude of the MJO is a good indicator of what's going on El Nino and La Nina wise. We're creeping up a little bit this year. Hopefully we continue on that trend. And here's where the fun begins. Subsurface ocean temperatures, all right? This is the West Pacific here. This is the East Pacific here. That same data from the TAO buoy array, series of buoys strung across the equator. These are the anchor lines on those buoys. The X's are the sensors on the anchor lines. You can see a bunch of them aren't working. So data is kind of spotty at times. You get all this data, gets relayed up, run through a computer, apply a model to fill in the gaps. You get a profile of the subsurface ocean temperatures. Warm water, the 28-degree isotherm, which for months was back here at 165 east, has moved considerably to the west to 175 east now, suggesting that trades are weakening here and the warm water is starting to bulge at least off to the east. The 24-degree isotherm getting thicker out in this region, pushing the whole way into Ecuador, suggesting again a more normal, or at least a somewhat return to perhaps a more normal water temperature thermocline angle resulting in, so the trades, when they're blowing strong, they take all this warm water, push it off to the east. When the trades relax, the warm water starts flowing back to the east. But it is not absolute temperatures. It is the differences from normal for this time of year. So here's our warm water, 4 degrees above normal. But so this, where's 155 east? Right here, that line right there. So this zero line had been here for months. All of a sudden, notice it's bulging off to the east a bit. And notice water temperatures are warming, not a lot. They were 3 degrees below normal a week or two ago. We're down to 2 degrees now. There's a little bit of warm water at the surface. This has been coming and going, but it suggests that, again, the trades are weakening. Another model, this is even more dramatic. It shows that where a full-on Kelvin wave is in flight, flowing from the West Pacific towards the East Pacific, currently to a point south 120 west. That's south of California. So see, there's a little bit of differences in the two models here because there's a bunch of sensors that are down in this area, no X's, right? So the models make their best guess at what's going on, but they generally are showing the same thing. But this one model, and this tends to be the more accurate model, suggests that there is a Kelvin wave in flight. We have not had anything like that for over a year now. All right, the sea level anomaly chart also showing very much the same sort of data. The first thing that jumps out is you see yellow there, where there hasn't been any for a year now. What are we looking at? So this is not temperatures. This is the height of the ocean. JSON-3 satellites strip out the waves, swell, strip out the wind waves, strip out the tides. We're just trying to see if the spherical surface of the ocean or of the Earth over the oceans is higher or lower than normal. So minus 5 centimeters. It has been minus 10 to minus 15 centimeters. This is the equator here. That's the date line there. That is Peru, Chile there, Central America, Hawaii hiding there, and New Guinea there, Australia. All right, so, and there's this big triangle that goes from North California out to the intersection of the equator and the date line, the whole way down to Chile, and trades over this whole region have been nuking either southeast or northeast or east, blowing this way, pushing warm water here. Notice the height plus 10, 15, 20, 25, 30 centimeters above normal, okay, because basically the winds have been acting like a bulldozer, just pushing the ocean in this direction, piling warm water up here. As long as the winds keep blowing, the warm water sits here. As soon as the trades back off a little, swoosh, the warm water, you can see it, actually trying to push off to the west. Same thing here. And warmer water expands, it'll create a bump on the ocean surface. That's what we have here. That's what we have here. Whereas colder water contracts, creates a divot. So you have two things going on, both the wind direction and the wind speed, and then subsurface ocean temperatures. But what this suggests is that warm water is moving to, what's that point right there? 120 west. Hey, that's just like that other model suggested, suggesting there's a finger of warm water under the ocean surface here, and that is effectively a Kelvin wave pushing off to the east. That is good news. That would suggest the demise of La Nina. Upper ocean heat anomalies, the upper 300 meters of the ocean. All right, this is the West Pacific here. This is the East Pacific here. These are the yellows, reds, warmer than normal temperatures, blues, colder than normal temperatures. Last April 2020, the last Kelvin wave, you can see it, warm water pushing from west to east on the equator. It ended in, we'll say, mid-April, and La Nina began. Cold water started building as east trades built. They backed off a little bit in July, and we got I wouldn't even call it a Kelvin wave, just a little trickle of warm water. And then La Nina started in earnest over that whole, from then until March now. But notice this, a rather large gusher of warm water starting to push off to the east. Now, the question is this going to be like this kind of event, a one-time little deal, and then the trades kick up again? We don't know, okay? But anything is a step in the right direction, okay? And now, remember, it takes 3 months for warm water to move from here. That's March 1st to the whole way over here. So that's all of March, all of April, all of May. So early in June, this Kelvin wave might erupt over off of Ecuador somewhere. Will that kick off an El Nino? No, we're not thinking anything like that. But it might get us to a position where come June, the ocean says, hey, we're back to normal. And then after that, so it's 3 months for the Kelvin wave to make it across, reach to the surface, start to normalize temperatures off of Ecuador. And another 3 to 5 months after that for the atmosphere to go, hey, something's going on the equator. Hey, it's looking more like normal. And then that would further erode the La Nina high pressure pattern, maybe help heal the jet stream. And then, so 5 months after June, you're into end of November. So maybe around Thanksgiving, then you'd say, hey, we're back to our normal pattern. And we'd maybe get a late start to the fall, but at least we'd have hope for a winter season and precip into California. Now, again, we're talking 8 months from now. And it's all on a what if and a maybe on a Kelvin wave that we're not even sure is really a Kelvin wave, but maybe is, and what might go on after that. But at least you get sort of a rough idea of how things could play out. Or La Nina could wake up and just start blowing, and the trades come again, and we're right back to where we were. So who knows? But that's why we sit here every week. We dig through this stuff. I look at it personally every day, try to sort of see how the soap opera is going to play out, look for some tea leaf signs of where we're going to go, because I like to know what the future has in store for us. And here's one other little chart. We don't normally look at this. Upper ocean heat anomalies graphed out over time, but all it suggests is, and this is for the whole area from the dateline to 100 west, so to the Galapagos, let's say, below normal temperatures, 1 degree below, going down to 1.4 degrees in November. But then all of a sudden, notice, boom, and we're in the positive, at least for what, 2 or 3 days right here. And the last time we were in the positive was right before La Nina started. So again, just some more evidence that things appear to be moving in the right direction for the moment. All right, we've talked this MJO thing. We've talked subsurface temperatures. Now I need to talk ocean surface temperatures, right? Because that's what really matters. The interface between the ocean and the atmosphere. If the surface temperatures aren't changing, then the atmosphere isn't going to change. All right, so Peru, what was that? Colombia there, Ecuador, Peru, Chile down there, all right? And the blues, colder than normal temperatures. The equator is roughly in here. These images sort of stitched together. But Ecuador here, notice warm water pushing off of Ecuador to a point south of California, 120 west, okay? Suggesting at least trades have backed off a bit. Now, the active phase of the MJO has been down here. That's what promoted California's precipitation. So it's no wonder that trades backed off and warm temperatures started building. But we do know that the inactive phase of the MJO is going to start plowing its way across the Pacific. Trades will probably pick up here. Much of this warm water might get wiped out. But we also know that there is some sort of a Kelvin wave, which it's with its leading edge somewhere right around here underneath the ocean surface. But on the surface, trades are still producing upwelling and cold water temperatures. So what's going on underneath the ocean and what's going on at the surface are two different things for the moment. This little chart, I've come to love it and hate it all at the same time. Past 7 days, sea surface temperature trend. Really gives you some very fine sense of what's going on temperature-wise. And these aren't absolute temperatures, just reds are areas that are warming, blues are areas that are cooling, and then you see broad areas that are pretty much staying the same. Yellow is, warming slightly. So basically, there's sort of a mixed pattern going on. Last week, I think it was pretty warm here. The week before that, it was very warm. All that while the active phase of the MJO was here. All that, of course, suppressing trades, allowing, or stomping on upwelling. But now with the inactive phase moving here, we would not be surprised to see temperatures start to drop in this region. But the Kelvin wave is still on its way. The overview chart here, too, showing significant erosion of the La Nina pattern. So the equator is what really matters, and we see warming here. That's super important. And we see cooler waters here, but much warmer than they were even several weeks ago, still reaching out over the dateline almost to New Guinea, right? And then there was this big finger here. This is really, if you figure there's high pressure here, which there is, and it's rotating counterclockwise, that's what it does in the southern hemisphere. This is the upwelling edge of that high pressure. But it is much weaker than normal. Temperatures they're still below normal, but much less below normal. They're like here instead of down in here where they were last year. And now off of California, another high pressure, right? The Gulf of Alaska, or what they call the Northeast Pacific high pressure, it's rotating clockwise. It's creating upwelling here, and that's holding pretty solid. That hasn't changed a lot, maybe warming slightly. So these are all little clues. What does it all mean right now? Well, we want to see what happens with the active phase moving out of this area and see what happens to trades before we start making any big pronouncements. And then what's going on with the ocean or the atmosphere above the ocean? We know the temperatures are warming slightly on the surface. There's a big change under the surface of the ocean. But what does the atmosphere is driven by temperatures in the ocean and on land, right? So what's the atmosphere doing? How's it responding? The Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Tahiti's in the Pacific. Darwin, of course, is not in the Pacific, we'll say more towards the Indian Ocean. When the index goes negative, it means pressure is lower over Tahiti, and that's what we want to see, that it can be driven by the active phase of the MJO or by El Nino. If the index is positive, like it is today, 8.85, that can be driven by the inactive phase of the MJO or La Nina. All right, today's value, 8.85, not particularly high, but notice it's been smattering of negatives here and there over the past month. Very positive back in February. Okay, but let's sort of do a 30-day average on this. 30-day average, minus 0.93. Hey, that's pretty good. Whoa, wait a minute, look at this. We were up at 15.25 almost a month ago, and we're down to neutral at the moment. That's a good sign. Okay, that suggests the active phase of the MJ is moving across the Pacific, which we know it is, right? But we also know the inactive phase is coming too, and that could theoretically drive this average right back up. The 90-day average, we call this the El Nino indicator. Okay, it's a lagging indicator for sure. It's at 10.14 in La Nina territory, but it was up, well, where are we? 15.75 here in February, and now we're down to 10, so we've knocked a good bit out of that. That's a good sign. Let's go look at the graph on this. And this pretty much tells it all. So, 30-day Southern Oscillation Index average. Back in 2019, we were in weak El Nino territory, negative numbers. And then this year, starting January 2020, and then really, typically, when you get this, when there's going to be a significant change one way or the other, it typically happens in the, we'll say, late January, February time frame. Last year, boom, the numbers just started creeping up and up and up. But now, we're in January, or we're past January, moving into February. We're rocketing down again. Now, the question is this just going to be like a one-year mini La Nina, or are we going to get down here somewhere and it's going to start creeping up again? That is the big unknown. We forgot to share this data when we were talking surface temperatures, but here's the graph. Nina 1.2 region, the area off of the Galapagos and Ecuador. Temperatures steadily on the rise, falling the past week, but still a third of a degree, 0.338, 338 thousandths of a degree above normal. Certainly not in El Nino territory, and this is not the official El Nino monitoring region, but better than being negative. And in the official El Nino region, the 3.4 index, now this is not subsurface temperatures, this is surface temperature, 0.393, 393 thousandths of a degree below normal. The La Nina threshold is a half a degree right here. Okay, so we've snuck above the La Nina threshold into what we could call the neutral territory. The question is, will the inactive phase of the MJO increase the trades, increase upwelling, and cause this sea surface temperatures to fall, which then would in turn support high pressure in the North and South Pacific? Or will the Kelvin wave that's pushing across the subsurface Pacific drive these temperatures higher and then maybe usher us into at least a neutral territory? So that brings us to our final frame of the evening. The official sea surface temperature forecast for the Nino 3.4 region, that's the official El Nino monitoring region from the CFS model. And good news here again. I think last week we were pretty much the same. And this is older data. This is from the 16th. It hadn't refreshed, but I'm sure they'll figure that out over the next couple of days. But you can see half a degree below normal. That's the La Nina threshold. We have risen above it. And the forecast now suggests that we're going to stay above it, somewhere in the third of a degree to 0.35 of a degree below normal as we get into the fall. That's fine. That's normal, borderline La Nina, but more or less normal. That's better than being down here like we were. We could maybe eke out a average winter with something like that. So the model, we're kind of looking to see the latest update whenever that comes out. Hopefully on Monday or Tuesday they'll figure it out. And we'd like to see this line inch up a little bit more. So there is some good news. We have a gale in the Gulf. That'll produce some surf, probably mainly for Hawaii. Lots of wind swell for California in the short term. A whole series of small southern hemi swells look like they're stacking up. Change of season is clearly in control, but at least we're getting some productivity out of the southern hemisphere, and we're expecting more to follow. The outlook is looking good. If we could just get the north winds to die down a bit, and they're looking to do that as we get towards next weekend, but I'm sure they will be back. It is still springtime, and it's a La Nina springtime and that typically means north winds in California and strong trades for Hawaii. All right, that said, looking out beyond, Kelvin wave in flight. That is good news. That's a major development. We haven't seen one of those in a year now. So any movement of warm water to the east is good news. That maybe could nudge us into a neutral or at least some sort of a normal setup as we get into next fall. Way too early to call how that's going to play out, but at least there is some hope in the models, and we're certainly going to need some precipitation as we get through next fall and into the winter. So any ray of hope, we will take it. All right, if you enjoyed the video, give us a thumbs up. There we go. If you haven't subscribed, please subscribe. If not, you can go to stormsurf.com. All the stuff we looked at tonight, all the charts are there, and we're again switching over to the new GFS wave model. So things are going to be a little bit rocky the first part of this week. Please bear with us. We are aware of the situation, and we're going to do our best to get things up and running for you. Yes, subscribe. If you haven't subscribed, go to stormsurf.com. We post the link to the video at the top of every page of the site. You can click it there and watch the video. Comments, always welcome. A thumbs up on the video. Appreciate it. It helps the algorithms, and if we can make a little money out of that, well, that's a good thing. All right, so that's it for this week. We will do it again next week, same time, same channel. Thanks for watching. See you then.